Hi, I thought I'd just share a little modelling tip which I found while modelling this mechanical arm, and it was to do with creating these weld joints around these various parts to give that little bit of realism to the model. And I found what I thought was a really quick way of doing this. I'm sure there are other ways of doing it, but this was my method. So let's say we want to create a weld joint around these two parts here, and these are separate objects at the moment. And with them being sub Ds, what I want to do is I need to freeze them first so that I can boolean one shape from the other, which I've already done, which gives you this shape here. And I've gone and deleted a whole bunch of polygons that I didn't need. So I just ended up with this profile where the two objects meet, the exact intersection point, as you can see. And once I had that, I just went around and selected all the points in order to create a path profile. Now if you look at this in wireframe view, you'll see that it's a really messy path, so you might want to go and clean up some of the points. I had to go in and just kind of weld average some of the points which were really kind of close together. The rail extrude tool kind of gets a bit funny when you've got points that are a bit almost on top of each other, really. So try it out first, and if you have any problems, just go and look at the points in that particular area. But the density of this doesn't actually really matter until because when we rail extrude this, we can control how dense the mesh is. So there's our path, as you can see. So the next one is to obviously create a weld profile, and we have just a disc basically. Now the kind of trick for this is to make sure that the number of sides is set to a level that when you rail extrude this, the quads that form the profile of or the actual shape are kind of square, and we'll see why that's important in a minute. So what I first need to do though is to put the path in the background, and obviously you can see it's not lined up, so you can either do that by eye, or if you want to save some time like I usually do, you can use a plugin called First Contact. Now this is by Pictrix, who's done loads of useful plugins for LightWave. This is the L-script version of it. There is a plugin version of it, but it's only 32-bit. So I'm on 64-bit Windows here, so I have to use the L-script version, which is fine, it works perfectly fine. So you leave it on connect mode, click OK. You can see it's obviously moved it onto the end of the path, and you can change the angle and the offset of where that is on the end of the path, but we want to leave it all on 0. And if I just zoom in on that, you can see that it's pretty much aligned to that path. And if I just flip that round, because we want it to go into the direction that the path's going to be going, and that's it. So now we just want to rail extrude this, so leaving the path in the background and the profile in the foreground. Control R to bring up rail extrude, which is on the multiply tab, I think, and you want this number fairly high. I've just put an arbitrary number in of 300 here, but you want it on uniform lengths is the important setting to have, and obviously you want it to be orientated to the curve. So if I click OK, what you end up with, if I go into full 3D view, you can see that the quads that make up this shape are pretty square, and that's, like I say, that's quite important. So if I just get these two end pieces now and just run the bridge tool to just merge them together. Now obviously when this path was created, the rail extrude does kind of twist the profile. It doesn't keep it sort of perpendicular to any particular axes really, so you'll get this little bit of twist here, but for what we're doing it doesn't actually really matter, but just gives us a fully sub D shape, which is important. And if I just set this surface of this to the body colour, so now if I put the arm in the background, you can see that we end up with this extremely neat weld. It'll take some professional welder a lifetime to get that good, but So yeah, so you can see what it's done. It's put this perfectly in line with those two objects, but in order to get it more kind of weld-like, what I did was I ran the jitter plugin, which is under the modify tab, and jitter, left it on Gaussian and just put the level down to 0.5 millimeter, and it just disturbs the points enough to kind of give it a more bumpy, globular kind of look. And you can play around with that and increase it or whatever you need to get the right look. So now if I put the arm in the background, you can see we end up with this kind of weld type shape. And if I just got this shaded view, you can see it's looking a bit more realistic now. So it's a really quick way of just doing that type of weld joint. And if you let's say you've created this now and you think, well, actually I need to really fatten up that weld, it doesn't look big enough, then rather than changing your profile and rail extruding everything, you can just go to the modify tab and under translate more, point normal move, and you can increase the size of your weld from something much thinner to something much fatter, to give a more chunky looking weld if you need it really. So and it works on the point normal, so everything stays completely in the right place. It just grows it out from itself or shrinks it in. So that's a really quick way of doing weld, I think. Just a point about the profiles though, if I just create a new disc, and instead of having 8 segments, if I say put it to 24 or something high like that, to get a perfect or more perfect sort of a circle even, you can see why this isn't particularly a good way of doing it. So if I just again line that up with the end of the curve and just flip the direction, if I rail extrude with the same settings, you can see what we end up with. If I go to wireframe mode, you can see we end up with these segments now where they're much longer in the direction of the path than they are going sort of 90 degrees to it. So you end up with more rectangular looking quads. If I just bridge them two together again, and the problem with that is if I run the jitter plugin now on that and do the same, you can see that what we end up with is a much more kind of wavy looking, which you might want actually, but it's much more wave-like as opposed to kind of globular really. So if I go to the previous one, you can see that one's a bit more kind of globby looking, and then that one's a bit more sort of wave-like. So you can change the look of how that weld appears by just changing the segments from either being square or long or whatever. So you can experiment with that basically. And obviously this is a sub D shape, and there's quite a lot of segments in it, so it's quite high poly really. So you might want to tweak that, and you can maybe tweak your curve and things like that to get it so that you don't need as many points. But yeah, effectively that's the technique really. Pretty straightforward. Yeah, and you can see it what it looks like when it's rendered. Looks fairly realistic, I think. So yeah, that was it really. Quick little modelling tip. Hope you find that useful. Cheers.